Hello, I'd like to have a look with you at this problem from section 3.2. And it's a problem where we're given a graph of a function, and this is the graph of f of x, and it says find the values of x in the interval from -2 to 2 at which f is not continuous. Okay, so continuity goes back to chapter 2, this concept of continuity, and in that section at the end of chapter 2, section 2.6, one of the concepts that's discussed there is some different forms of discontinuities. You can have a discontinuity where you have an infinite discontinuity. You can have a jump discontinuity. And another type of discontinuity, which is what we see here in this graph, is what's called the removable discontinuity. Okay. But again, this concept of continuity, one way to think about it informally is just this idea that can you draw the function without lifting your pencil or pen off the page? And in this case, at this removable discontinuity, that's a place where we would have to kind of break the graph and say, hey, we've got this other point over here. To get to the definition of of continuity, what's wrong or where this breaks down in terms of continuity at a point is the limit as we approach 1 is different from the value the function takes at 1. So, having said all that, the answer here is x equals 1. That's the one and only point in the interval that they gave us where f is not continuous. Okay. There's a part B to this which addresses a concept from this section, differentiability. This is find the values of x in the interval from -2 to 2 at which f is not differentiable. Okay, now the concept of differentiability is different from the concept of continuity, although there is a connection there. Anytime a function is discontinuous at a point, it's also not differentiable at that point. But it is possible to fail to be differentiable but still be continuous. And that's really at the heart of what this problem is kind of pointing out to us. To be differentiable at a point just means that the derivative exists, or the derivative is defined at that point. And that's why when at a discontinuity, you can never be differentiable. So this is not differentiable at 1. Okay. But it's also not differentiable at 0. So at both of those places, the function fails to be differentiable. And the problem with what's going on at 0, even though the function is differentiable, it's got this kind of corner there, or cusp. And if we were to think about what the tangent slope would be there, well, there isn't one. And it's exactly because of that feature of the graph. And whenever you have some kind of corner or cusp at a point, the function is not going to be differentiable at that point. And there is one other way in which a function can fail to be differentiable, which is if you have a vertical tangent. Okay, that's another place where the function is not differentiable. Talking about places where the function is not continuous, and then these corners or cusps. Okay, thanks for watching.